So, you may notice that questions 21 and 22 are already filled in. I just got done working all four questions, actually 21, 22, 23, and 24. And I thought that I was recording, and it turns out I wasn't. So, when I went to end the stream, I ended up starting it. And rather than go and rewrite all of this again, I'm just going to walk you through it, okay? So my apologies that it's already done. You can already see the answers, but let me walk through what I did. So 21 through 24, you're supposed to prove that functions are inverses by using the composition of function. What that means is you show that f of g of x is equal to x, and g of f of x equals to x. So on 21, we're given the functions f of x equals 4x minus 8 and g of x equals x plus 8 over 4. We have to go and do both compositions here. So I started with f of g of x. That's going to look like this. 4 times x plus 8 over 4 minus 8. I took the f definition and I put the g definition inside it. Now what happens is the 4's cancel because multiplication and division cancel, and it leaves you with x plus 8 minus 8. And plus 8 and minus 8, they cancel, and you're left with x there. Then I went and I worked the other one, g of f of x. So I took the g definition, and I plugged the f definition into it. And what happened was then these 8's canceled and left me with 4x over 4. And 4 over 4 was just 1, so I ended up with x, which means f of g of x equals x, and g of f of x equals x. And that means that they're inverses. So I wrote a big yes because that's important. On number 22, we're given f of x equals x over 5 plus 9, and g of x equals 5x minus 3. So I started with f of g of x. I took the f definition, and I put 5x minus 3 in the top. That's where this came from. And I said, okay, I need to simplify this. So I divided 5x and then divided negative 3 by 5. Now 5x divided by 5 is just x. Negative 3 divided by 5 is negative 3/5. It's like, okay. And then I put my two like terms together, negative 3/5 and 9, and I got negative 8.4. So I ended up with x minus 8.4, which is not just x, which means this didn't work out. And if this didn't work out, there's no point in doing the other one because it's not going to work out either necessarily. But if this doesn't work out, then you know they're not inverses. So I put a big old no right there. Then I flipped my page over and went to number 23. F of x is equal to 1/5 x minus 5. G of x is equal to 25 minus 5x, or plus 5x, excuse me. So I started with f of g of x. That equals 1/5 times 25 plus 5x. I distribute, minus 5 in the end there. I distributed the 1/5. A fifth of 25 is 5. A fifth of 5x is just x. So I was left with 5 plus x minus x. And I realized that 5 and negative 5 canceled out, so I was left with just x. Then we have the reverse, g of f of x. So I took the g definition, 25 plus 5x, and I replaced the x part with 1/5 x minus 5. That's what this is. I distributed the 5. 5 times 1/5 is x is just x. 5 times negative 5 is negative 25. So I was left with 25 plus x minus 25, and I went, 25 and negative 25 cancel out, and it leaves me with just x. So I have f of g of x equals x, and g of f of x equals x. So that means yes, they are inverses. On number 24, we've got f of x equals 6x minus 10, and g of x equals x plus 6. I'm sorry, x over 6 plus 10. So I did f of g of x. I plugged the g function or the g definition in to the f definition. So I got 6 times x over 6 plus 10 minus 10. And I distributed the 6. When I did, 6 times x over 6 is just x. 6 times 10 is 60. And then I got minus 10 on the end. I combined my two like terms. I got x plus 50. Well, that's not x, which means this stuff is not going to work the way I need it to. It means they're not inverses. So I didn't bother trying the second one. I just said, no way, Jose. We're good to go. And I wrote a big no here with two exclamation points, because I was very, very certain. And that was all.